Record, right? Record. So it's recording now, yeah? Okay. Let me somehow wipe this file off my face now.
You're gonna have fun in the editing room later.
Yeah. Okay, okay. Deep breaths, yeah? Hi everyone, today I'm gonna go through my four-way junction. I coded using STM IDE, using an STM32 controller, microcontroller. We have our four-way junction here with 4 traffic lights. Each traffic light has also a push button. Everything is connected through the breadboard to the microcontroller, then to the STM IDE, where we are coding in C language. So it functions on a continuous loop with north-south and west-east. Traffic light UK system. These guys, when they see green, they can go right, forward, and to the left. So we see here, when this one is red, this one here is green, so these guys can go, these guys will wait. And also, when we press the pedestrian button, all traffic lights turn red. So now it's the pedestrian phase. Here we go, it ended. We also have an emergency button to simulate an emergency vehicle. So when we press this button, the blue LED and the buzzer will go off. Well, we're gonna cut this one out.
I think it's in the wrong way around.
See? We also have here the code. We used different phases to help us code the FSM state better. We're using if, we're using cases, basic stuff, states. We have a state for the emergency, state for the pedestrians, and then each phase in the traffic light has a state as well. We are also coding the settings for the clock. The clock is important to make sure all the traffic lights are running smoothly. And we also coded internal pull-up resistors for our buttons. Okay, let's see what's wrong with the this one.
Sure the LED's in the right way around.
Oh, here we go. Emergency works as well. So that's it. This is our four-way junction. All done. Thanks for watching. That's it. So we have two main files of code. The main H file, which is a header file. This is where we define the pins, we give them names. I haven't used the names. This was more like a list for me to save and look back of what each pin represents. So in red, this is the north LED from the traffic light, is represented by PC0. Same for all of them, nice and clear for me, ready to use here. So main C, our source file, we include the header file. We are starting the system clock configuration. We have some helper function. These functions help us later on in the code, so I don't have to write this whole pin, all of those pins again. I'm just writing this specific function. We have a pedestrian phase, an emergency phase, a traffic north-south phase, and a east-west phase. All these phases are same as in UK, amber on, amber off, green on, red off. They all it's labeled out clearly. So when I first started to code, I tried to make just a simple loop. And it does work if I'm just using north-south and east-west phase. But when it comes to introducing an emergency phase and a pedestrian phase, things get more complex. It's not as easy. So what happens is I'm using a find state machine, multiple states. The emergency has a state, the pedestrian has a state. We have a north-south phase, so on. You can see here. So we are creating a loop handler to help us with the main loop. So we have a block of if statements. Emergencies first. Emergency has priority because the moment we click the button for emergency, everything stops. So the emergency vehicle has priority. Pedestrian is they have to wait. They click the button, then as when the north-south or east-west phase ends, then the pedestrian phase can start. So we have a case statement block here where we have different states for everything. And the way I coded it is only when it's green for the traffic light, only then the pedestrian can press their button so the pedestrian state starts. Then when it's gonna turn red, it's gonna stay red so the pedestrians can all pass. Yeah, so we have different states for each traffic light state, different timing. Everything has a specific delay. Everything works as expected. So this is the only thing we have in our while loop. That's it, just the loop handler. So we have all the logic here for our loop. We have our system clock configuration here. The right clock has to be used so things don't crash, things can work properly with the right delay, everything. And our MX GPU here, we are setting each pin as an input or output. We are coding also an internal pull-up resistor for the 4 pedestrian buttons and the 1 emergency button. This is pretty much it. Thanks for watching.